Problem 27, remove element. In this problem, we have an array from which we have to remove all occurrences of a given value. And the way we are required to do this is to do this in place. So we have to create a new array where, we do not have to create a new array. Everything has to happen inside this nums array. So this number 1 should stay here. Number 5 should disappear. So 7 should move to the left. Well, 5 would also disappear. 1 would stay. 1 would stay in the array, but it would move to the left. 5, both disappear. This is okay, so it has to come here. And the same for 3 and 1. They have to. So, and then whatever happens here does not matter. We can just leave the whatever values were there or anything. This is insignificant. But after mutating this nums array in this way, we have to return the length. That probably makes sense, because since you're returning this entire array, we should be able to distinguish where this meaningful data ends and garbage begins. So we have to return the size of this meaningful part of the array. In this case, that would be 6. Okay, so in order for us to do this, I think we can just follow that algorithm that I pretty much outlined here. So we will have 2 pointers. One pointer will be, let's call it length. So the first pointer will start from 0. This will be the destination where we are copying to. So it's this slot right here where I will be copying the elements that are okay. So the second pointer, let's call it I will be running through the entire array from the beginning to the end. And we will be checking each element I. So when we check each element, when we check element I, if it is okay, if we then we should just copy it to this spot and instantly increment our pointer length. So this will be the next spot that we'll be trying to fill. I will move here. Well, this element is not okay, so I will move here. This element will end up to be okay, so we'll copy it, increment our length, and basically that will be the algorithm. Let's try to implement it now. So as we said, this variable will live outside of the loop. And the reason why length will live outside of the loop header is because it's required. We should be returning length in the end, right? So inside the loop, we will say let I equals 0, I should be less than nums length, and plus I. Now, what we're going to do here is if nums I is okay, so it doesn't equal val, then we should take nums length and assign to it nums I, right? And when we do this, after the assignment finishes, we're going to increment the pointer. So I will increment at every iteration. However, the second pointer length, which is the final length, will only increment when we pick a valid element and put it into the spot. So length is final length of after filtering out val. Okay, I think that is pretty much it. Let's test this on the available simple tests. Okay, both were accepted. Now we can go ahead and submit this. Okay, beats 100% of option, 100% of other solutions in terms of runtime. In terms of memory, we didn't do very well. How is that possible? I mean, we just used two integer variables. So it's probably not possible to do this with significantly less usage of memory. Maybe other languages like C++ have just a lower overhead in terms of JavaScript being a interpreted language. So this would not be possible to make this more efficient in terms of usage of space. Let me just submit this one more time. So 55 megabytes and 30%. Let's remember that. And I'm going to submit this one more time and see what happens. Okay, so without changing anything, we have achieved significantly, well, somewhat less usage of memory and a significantly better performance. So I don't understand what's going on there. Let's just say this is somehow inconsistent. So, well, this is a decent implementation of this problem.